right? So here, as promised, the video update on what happened over the last 2 or 3 months already. So as some of you might know already, because I dropped a few crumbs in the chat, I was working on the instant finality milestone together with the UX team. So shout out to Guillaume, who kind of onboarded me, I guess. And it's actually quite interesting because for everyone who was around already in the early days of ZEOS, when I started with all this, the very, very first thing I did was porting the Grow 16 ZK Snark verifier from Zcash into an EOS smart contract, because obviously that was the first thing that I needed to figure out if that works and how that works in order to build such a protocol on top of it. And back then, I had a pure C++ implementation of the Grow 16 verifier from Zcash. But as you guys might remember, for those who have been around, it was way too slow. The proof verification took around 150 milliseconds, I guess. And that was way too long and too expensive. First of all, there is this 30 milliseconds transaction limit on EOS. And then, of course, it would also be very costly to execute transactions that long. So that was the first issue I ran into. And this is how this whole vCPU / liquid dApps thing basically came into the project, right? Because it was the only way to build such a protocol on EOS, because without some crypto primitives or some precompiles that you can execute as host functions from a smart contract that would speed up the execution, it wouldn't be possible without the dApp network. So that's how this all started with dApp. And of course, I was planning right away from the beginning to use VRAM for the Merkle tree and all that, because that is just a perfect application for that. Now, long story short, as you guys know, the dApp network is not really existent. I mean, we have this tag, right? But there is not really nodes operating. So for me, it was the only way to proceed back then. So this is why I chose this path, and I'm happy I did, right? Not only did I build this demo application already back then based on vCPU, but then, as you know, I started all over again with the Halo 2 stuff, which was also all based on vCPU as well. With Halo 2, this is a whole different story. I will get into that as well. There's also, that's the reason why I wanted to do this on video, even though it's not so easy for me, but it's way too much to explain all that in a Telegram post. So I was working on setting the DSP up, right? And the DSP, I have one up and running, right? But as far as I know, this is probably the only one that's currently on the mainnet. And then I ran into issues over and over again with trying to execute my vCPU transactions, basically. So I saw your messages already in the chat regarding help and all that. Now the thing is, I don't really need help with setting up a node. I need people who run nodes. I don't want to have to deal with this issue at all. That would be the best case scenario. Normally the dApp network should just be there and being ready to use, right, for applications, but that's not the case. So that's just additional workload that I have to deal with now, instead of being able to focus on what actually matters, which is the protocol itself. So anyway, with this BLS library that I built now for the instant finality milestone, that's what I shared in the Telegram chats. This is a very, very high performance implementation of the elliptic curve arithmetic around this BLS elliptic curve, which makes things like pairing and all that is super, super fast. And now, because of the instant finality milestone, this library is going to be added into Leap, and some of these very, essential functions, arithmetic functions, are being exposed as host functions to smart contracts for them to be able to make use of them. And that's super exciting because now I can basically build a Grow16 verifier based on these precompiles with much, much better performance than I had back then when I started this and had this pure WASM version of the Grow16 verifier, which again was 150 milliseconds now at one proof verification. With a new verifier based on these intrinsics that now are or will become available in the next big Leap version, hopefully, it's possible to have a proof verification of only 1.5 milliseconds. So this is significantly shorter, of course. It's a factor of 100 almost. Is incredible. I would have never thought that this is even possible, but it is apparently. I mean, these are benchmarks from my laptop here, which is a new laptop. So much faster than my previous one, but still probably slower than a block producing node or a machine there. So these numbers might even be better on the mainnet later. So very, very promising and absolutely game changing for me. So because obviously it is a good thing to get rid of this DApp network dependency. There's if it can be scalable and affordable, natively on chain, with a different proving system maybe, but we'll talk about that in a second. But at least there is no other dependency anymore, and especially not a dead project like the DApp network, because that's unfortunately how it is. If there were 20 DSPs on the mainnet or something, and this was a flourishing, ecosystem on its own, where you would see dApps building on and all that, you would have node operators, running all this. That would be a whole different thing, also from a selling point of view, right? Even though you can make the argument, and I wrote about that in the past, that having a set of extra nodes that are doing proof verification is not really a security trade-off. It still just doesn't look so good, right? As something that you can just deploy natively on an EOSIO, on any EOSIO blockchain, right? And it works without the need of any additional infrastructure. So this is of course a huge benefit and a huge plus for the project. However, someone was asking why am I throwing away what I built? So I'm not throwing away anything. If people set up DSPs and I'd say, I'm just able to deploy my stuff the same way I was able to do it on Kylan, right? With Net, who was running the node there. So if something like that would exist on the EOS mainnet, I will deploy it right away. It's all there. And by the way, it's all open source, so anyone can deploy it. But obviously, I would do that, for sure. I mean, obviously it wouldn't be so easy for anyone to do that. I mean, there is a certain complexity to all that. There are two vCPU handlers, and yeah, then you have the contract, of course, and then we have the whole client side of things, the browser application, which is a massive, complex app on its own. But it's all there, and yeah, it's ready to deploy. So if we have nodes available, that would be great. And also, I want to say this, because I saw that in the chat, for the whole Web3 stuff, I need something like liquid storage, or it would be great to have something like liquid storage anyway, right? An IPFS storage solution. But, it's good that the protocol doesn't depend on something like that. When we're talking about hosting our front end, this is a whole different thing. Having liquid dApps or whatever is available for that, great, yeah. I don't see anything of that being added to Antelope or EOS.io anytime soon, right? What I'm talking about is a solution to host your front end in a decentralized way as well. Doesn't exist, so we need something for that anyway. But the protocol, the Halo 2 version of the protocol as I built it over the last months, depends on liquid storage for proof upload. It depends on, to get the proof verified, it has to be uploaded into liquid storage. It cannot be passed to the vCPU handler from the blockchain or from the smart contract right away. So those are all very ugly things. A lot of people don't even understand what I'm talking about, but I know exactly what I'm talking about. I built this thing, and I know there are a few things, I made it work, and I'm proud of it, right? I mean, it works. It would work, if we would have, again, some working DSPs with people who maintain it, who are, operating these nodes, other than me, because, really my time is wasted on that, guys. It would be a total waste for me to just spend my days on running a DSP and debugging the software and all that. It would be great if there's some people doing that, and I would even pay someone. At this point, I can't even afford, thanks to the library that I built and to Guillaume, who onboarded me and who's really financially supporting me a lot. I could even pay someone to not having to deal with it, but then and I would, yeah, but the thing is, it doesn't even get me that excited anymore, yeah. And again, I'm not throwing away anything. It's all there, and I will reuse about 80% of the code. So someone was also asking that, will it take another year? Certainly not. As I said, I 100% I will have the protocol ready for rollout before these BLS primitives become available on EOS, so which hopefully is in September this year. So from my understanding, this could be the next hard fork, or at least where the lead nodes are being updated. But let's see. Yeah, the point is that as it's gonna, in one form or the other, it's gonna become part of Leap. So these intrinsics will become available, because it's the same tech that's being used for instant finality, which is currently being worked on. So and with 1.5 milliseconds grow 16 proof verification time, we can build exactly the protocol that I had in mind, with private deposit and withdrawals, with users being able to have very complex but private DeFi transactions, where you have multiple UTXOs being burned and minted and all that in one transaction, that requires several grow 16 proofs to be verified and processed in a short amount of time, because you want to have it as cheap as possible. You want to scale, but yeah, you guys know 1.5 milliseconds for one proof is nothing. I mean, almost nothing, right? Someone could spend 10 UTXOs, which probably in practice will be a very rare case, and still that would only be around 15 milliseconds, which is just just for the proofs. I mean, there's still some more transaction overhead, but you can then add maybe another 5 milliseconds. So I could see this possible now with the numbers that I already benchmarked and produced. So this is very exciting stuff, So I will maybe just repeat that again because I know also sometimes things are not getting understood right away, the way I explain it. So the BLS library that we built as part of the instant finality milestone, again, it was never planned at the beginning to build this whole new library. There are already libraries, but the one I built is faster, has no dependencies, is really, really perfectly tailored for Leap, you could say, and no ZEOS. And of course, since I was also planning to build on top of it, I also maybe took a little bit more effort to make it really, really good, to get the maximum out, because that's what it's all about. And I was blown away by these numbers myself. I didn't expect it to be even possible to get in this very, fast, or how to say that, in this low range, low timing range of 1.5 milliseconds. This is incredible. I'm down from 150 milliseconds with pure WASM verifier down to 1.5 now, which is really a factor of 100. Absolutely incredible. If you guys remember, there was EOS Rapid, I guess, was the team who built a Growth 16 verifier and an EOS contract as well, with the precompiles of the BN elliptic curve. It was, I think, the first antelope version after the name change, September last year, I guess. And the proof verification, I think, was around 11 milliseconds or something. So we're even from that, and when that came out, I thought, okay, it will never be possible, right, to get significantly lower than that. I just didn't expect that, because that was already based on precompiles. But the library that we build now for the BLS curve is just significantly faster than the code that was added for the BN curve. And that has to do with and that sounds crazy to anyone who's a developer, but these elliptic curve operations can be implemented very, very efficiently if you write them directly in assembly and not as C++ code. And there's a certain reason for that, why this is so much more efficiently. Essentially, it boils down to being able to carry over the carry flag from one integer operation to the next. This is only that you cannot express that properly in C++ code. So, but in assembly you can just just carry over the flag. This is amazing, and that saves you, like, I don't know, it speeds up the code dramatically, by a factor of magnitudes. It's unbelievable. So I didn't expect that, and that is basically the whole story behind why I see great value in starting all over again than spending my time on DSPs now. Because if this is now all of a sudden feasible and also scalable to that degree, there is no reason to rely on DApp anymore for anything. And again, it won't take that long to rebuild the protocol. Again, it will take longer for the intrinsics to come out. But instead of setting up DSP nodes, we could also set up just a small EOS testnet where these BLS primitives are already enabled, and then just to showcase the application. But yeah, maybe there's a testnet that will activate these protocol features a little bit earlier already. Anyway, I will be able to build and test the application here on my local hardware, because I have the leaked version obviously here and can already play around with it, with these new intrinsics. So yeah, that's pretty much it. Yeah, I also don't want to make it too long. It was not as organized as I planned it, but I will just let me just go through the questions here in Telegram real quick. So yeah, a lot of people were of course super excited about these news, and there's really no reason to be not excited, but I understand that people were hyped about seeing this now on the mainnet already based on that, but yeah, it is a painful thing dealing with that. That's what I can say. And again, I'm not opposed to roll it out. Also, I want to make that clear. Yeah, I'm happy to have these two protocol versions and also be able to compare them. Maybe there is great value in having these extra nodes for the protocol. The only value that I will see in Halo 2 right now is there's also another thing I wanted to explain real quick about Halo 2 and Grow 16. I didn't go into the differences there, but just real quick, the benefit of Halo 2 was especially the trusted setup is not required anymore. So that was one of these big, points always about these ZK snark coins, right? That you have this trusted ceremony at the beginning to make, and that needs to be safe, right? In order for fraud to not happen by these people who created these parameters in the ceremony. Now that's one thing. Okay, you could say that is the biggest downside, of going back to Grow 16. But other than that, there's actually only upside, and I want to explain that real quick as well. So we are on a general purpose smart contract blockchain. We're building a privacy protocol on top of a general purpose blockchain, like EOS, right, or Ethereum or whatever. But it's not an application-specific blockchain. So our environment is fundamentally different. Okay, we are inside a smart contract. We don't have multi-threading there. We only have we're kind of limited, in what we can do. Everything is compiled to WASM. We don't have the same library support and so on and so forth. Only 30 milliseconds transaction execution limit and so on and so forth, right? I mean, there's so much limitation. This is different, right? When you have an application-specific blockchain like, Zcash, for instance, right? You have the Zcash node software, right? And if you develop the protocol, the privacy protocol natively into a node software, right? Then you basically have all the benefits that you have from developing for your host machine. You can use any library, you can use multi-threading and so on. Intrinsics, right? Or CPU features. So why am I saying all this? Because Grow 16 is actually the better proving system for this kind of smart contract environment. Because the proof verification is always constant time and is as fast as it can get for Grow 16. It's really, the proof size is very, very tiny, and also the verifier key is relatively small. And the execution time only depends on the number of public inputs. Halo 2 only shines actually when you can take advantage of multi-core execution on the verifier side. But that is not possible inside a smart contract. So I just wanted to clear that up. This is why Halo 2, for protocol built inside a smart contract as we do it, because we build it for a general purpose blockchain, it's not built on its own application on an application specific blockchain. So that's a big difference, and why Grow 16 is actually better for the environment we are in. I learned so much over the last years. Yeah, I also want to make that very clear. In German, we have a saying, all good things are three. It basically means, it's a very old-fashioned way to say, you basically have to start all over again for 3 times, or the third run, or the third approach or try, you could say, is going to be the one that's going to be really good, where you finally get it, where you finally have it, right? Have it all in place. And I have to say, now starting again for the third time, the way I approach this now, and like the whole thing becomes so much more professional now, because I always read these threads on GitHub, or the Zcash devs. They discussed everything there, and you can really follow it and understand all the design choices they made and why they made it the way. And I'm really able to follow everything at this point, right? I mean, that wasn't the case when I started with all this, right? I mean, the demo application I built was definitely secure. I know it. I mean, that the cryptography side was secure, but it was just not so pretty, right? I didn't know how to. When I didn't understand it fully, then I avoided adopting it, but rather did it in a way that I understood why it works that way, but it was not necessarily the prettiest solution. So that changed already a lot with when I started with the Halo 2 stuff, because it was basically the entire Orchid application, because I was not constrained anymore by the smart contract limitations, right, and by EOS.io, because I was already moving everything to vCPU. Basically, I was already expecting the set of extra nodes. So I didn't only put the proof verification off-chain, but also the Merkle tree operations, because of the circuit-friendly hash function that we used there, that was used in Orchard. And we would need pre-compiled for that in EOS.io as well, to have that efficiently executed inside the smart contract. So I offloaded that as well, and it was nice because I could port the entire application really the exact same way it is deployed on Zcash mainnet today, the latest upgrade. I could build that, just modify it where necessary, to enable multiple token symbols and all that, multiple token types. But other than that, it was the exact same application. I was able to port that to EOS, and it's there. I have it there. But it depends on the DSPs. It's not possible without. But it is already the exact same application, so much prettier than the demo app. But now, the way I'm doing it now is that I really understand the environment I'm in. I not just try to port the Zcash application, the latest one as is, because I understand that for this environment now, it is actually not tailored in the most optimal way. So I would like to retailor it so that it is, and starting with the proving system, choosing the right hash functions, all these things. There are so many things to that if you really want to do it right. And now I understand all this, right? And I can really tailor the protocol, in a way that it is really like that I can argue it is the most optimal way for Antelope or for EOS.io, say, without any additional dependencies. Also for the Merkle trees, no VRAM, nothing. I will just throw everything out. That will make it a little bit more expensive, of course, but it's fully on chain and it can be deployed to any Antelope blockchain. Which, by the way, is also the reason why I will not. From now on, I will keep my development for first. Closed source. Of course, I will open source everything at some point, but not right away, because it will be much easier to deploy it now, because of all the dApp stuff will be gone. And I want to keep the advantage for this community, for ZEOS, but also, of course, being able to sell it, and have it, So the way I'm gonna do it now, or the way I was thinking about it, is we will probably be able. So there's a couple of different things. If we proceed with the DSP stuff, we can also continue the development with the UI and all that. If that happens, then we could probably also reuse that a lot for the fully on-chain version of the protocol. So there will be two versions, because the other one is already done anyway, right? I'm just not so excited about it anymore, because that network is just a pain. It's just a pain. But anyway, if for if there are not enough people say, hey, we want to see this now, we have support from Tal Muscal even, right, to set up nodes. I just don't want to have to deal with it. That I will help rolling everything out, of course. Yeah, I mean, I want to see it as well. For me, it's also kind of frustrating, right? When you work on all this and then you're actually at the at the stage where you now want to, or you can demonstrate and you're able to showcase it, and then it's still not possible, because then you have to get this done and this done and this done. It's just a never-ending thing. Yeah, I set up this DSP on a fresh Ubuntu. It was complete fresh VPS, fresh Ubuntu 22, and a fresh installation of DApp and all that. And the first thing I have to do is debug the node. Yeah, sorry guys. I don't know. I'm not saying it's not worth doing it. I'm just saying, my time is wasted on that. I rather keep developing these things. And I also need you guys to understand how early we still are. My roadmap is changing on a monthly basis, not because I'm unable to finish stuff. No, I already finished the demo app. I finished now the Halo 2 app, and now I'm going to finish the third application. And those are 3 working applications. Okay, I finished everything. But still, things are changing so quickly because the environment is just changing. Also, I wasn't aware that these things would come to Leap, right? I mean, only because Guillaume approached me and kind of introduced me into what they are doing and how close this is actually related to what I did at the very beginning with ZEOS, with the whole Bro 16 stuff. That's also something I didn't even know that was going on. Yeah, and now it's so funny. Yeah, if you think about it, now I'm adding myself, right, these host functions to Leap that I would have needed when I started with all this, right? How hilarious is this, right? I mean, what a coincidence is this, that I'm now doing exactly this, but for a complete different reason, right? The reason is instant finality and not the ZEOS protocol, but it's exactly what I needed back then to make this work. And now, because I did it, because my interest in this being also like best possibly implemented or best possibly done, because of my high interest in that, I spend so much time on it now, and to make it really, really fast. I mean, it's like brutally optimized to performance. Yeah, and I'm really proud of this library as well. It's a really nice thing. And I think, to my knowledge, it's the fastest BLS implementation that you find right now. Okay, there are not so many libraries. I listed them all in the on the GitHub README. You can see it. There's the Ethereum implementation, which which was my reference implementation. So, it's not that I came up with the assembly code myself. It's their audited. It's a portation of their audited Go implementation, which has partly these assembly routines, and I ported all that to C++ with GCC inline assembly. So it's pretty much identical, but it wasn't that easy. So this is slightly different, but it's pretty much the same number of instructions and all that. So yeah, anyway, all that to say, it's an awesome library. I took very much care that it is very efficient and very performant. And yeah, sure enough, it is. And I'm now able to really build this whole protocol for, again, not just private peer-to-peer, but also private peer-to-contract transactions, fully on-chain on EOS. And yeah, that's just awesome. That's super exciting. And yeah, again, it won't take me that long. I'm already in the middle of it, basically. Yeah, my work for the hot stuff milestone is more or less done. The library is there, it works. The aggregate signatures, that was one interesting feature. And yeah, the Grow 16 stuff is the part that I'm interested in for my project, and that is exactly what I'm now utilizing. Yeah, and I already developed that. So when these features are being activated on EOS, my protocol, I mean the new one that I'm building now, will be ready for rollout. So it is already quite long, I guess, but let me go through a few things here. I was also thinking about making this live, maybe that we can just talk and the questions come right away. Now I have to read it, but just give me a second. So again, I'm happy to roll that out if there is a debt network. Yeah. No one would like to see this more than me, probably. All right. So yeah, I hope the disappointment is not too big. Again, I need you guys to understand how early we still are in all this. We are so early. It's incredible. We are innovating so fast. For instance, what I'm building now with these private contract, peer-to-contract transactions, like or private deposits and withdrawals, right, which will enable basically privacy for any application based on these ZEOS wallets, right, which are basically just like a normal Zcash wallet, but you can hold all your EOS assets within. So the user experience will be like that from a legacy cryptocurrency, but with all the benefits, with EOS under the hood, basically, right? I mean, so cool, and I don't see so much in that regard happening yet. I'm sure teams are working on this on other ecosystems, but I think we're definitely. I mean, it's difficult to say, right? Are you ahead? Are we behind? I mean, I don't see even the competitors yet, right? But my feeling is we're probably very far ahead already with what we're building. If you look in the space, the whole space is a complete joke, right? There are really only a few developer teams who really seriously work on stuff that actually matters, I mean, that's really just how it is. And I'm happy to be more involved now with these kind of dev teams in the Antelope ecosystem, like UX and the amazing engineers also at the ENF. I'm having the pleasure of being on weekly calls with them now, together with Guillaume. Again, shout out to him who made all this possible. It's awesome, yeah, and there's a lot of cool things to come. Yeah, I can say that. Yeah, I'm just saying, yeah, we're super freaking early still, and don't worry, yeah. All the experience, all the work that I did, it was not for nothing. Yeah, it sounds so like starting from scratch again. Sounds like everything I did was pointless or worthless. It's not. Again, I will reuse a lot of the code. I don't know how many Merkle tree implementations I already have, or based on different hash functions and all that. I mean, I have like so much. I built so much stuff already, and it's gonna be very easy for me now to do this third iteration of the protocol. It's so much stuff is already there. I can reuse so much, and it's gonna be so beautiful because everything is really just within the contract. I mean, there will only be the smart contract right on the back end, and then we'll have this browser app, and yeah, there's this whole Web3 stuff. There's so much cool things that are there to build, and also the Fractally application. But yeah, let me just go through a few things here. So yeah, I don't drop anything. We're gonna reuse it. We're gonna refine it. Yeah, we're iterating here. We're innovating. That's what we're doing, and it's getting better and better. We're not moving backwards. Don't get this wrong. And again, I'm happy to do it with Deb. But yeah, some people need to spin up nodes. Yeah, I thought, so okay, let me also say this real quick. I did this. I even put this instructions manual together. If you follow this, you will be able to spin up a node. But the vCPU modules are not there where they should be, right? So you have to fix here and there. And if it's even for me such a hassle, I don't even continue bothering writing this manual for people who are not even familiar with Linux, right? I mean, it's just nonsense, guys. It's nonsense. And it needs to be people who are experienced with not just with Linux, but, obviously, unfortunately. And then, sorry, but I didn't know that as well. I thought, it was really just like that. I know, and there's no criticism about Nat or so. I know he was maintaining all this. He was putting out new releases of the ZEOS SDK all the time. And I thought it is very well maintained. And, once, if you provide proper instructions, people will just be able to spin up a node, ZEOS, right? And then the DSP stuff. And then that's it, right? And then, of course, you will have then also people learn while they are operating their nodes and all that. But I don't know, I don't see it happening. I would have to initiate all of this. I would have to provide support for everyone. And, guys, it's just too much. Yeah. And this is also not the idea. Yeah. I'm not here to become the new main developer or to kind of fix this project. I mean, I would if I had to. If that was the only path forward, I would do it. You would see me doing this now, because that would enable me to build what I want to see, which is the ZEOS protocol. But now, that we were able to improve the Antelope protocol with these amazing, and again, this awesome library, which is really, really fast and enables now these cool applications on top of it. This is just so awesome. Yeah, I'm so hyped, and that gets me so excited. And that I don't really feel like following this other path anymore, dealing with DSP, which is a dead project. But that doesn't mean that I wouldn't, roll out my thing right away. Yeah, as soon as nodes are there. So please get that right. I don't, if there's a dApp network, I will roll it out, and, there will be a UI and all that. But since it's all up to me to make this happen now, I will just proceed with the way more promising and interesting path. And yes, it takes a little longer than. So that's how it is, guys. Yeah, this is how early we are. So please don't be disappointed. There's no reason for that. There's no reason to be disappointed, but every reason to get super excited. I'm more and more involved with the protocol development, and being an application developer myself, with also such a massive application, it's just so beneficial to be kind of involved into the protocol stuff as well. I can give feedback, to people like Eric and the other top engineers there who are maintaining the code base, who I believe are also happy to receive some feedback from people who are actually building on top of it, right? Because that gives you some idea, right? What are the needs and what would be of interest and so on and so forth. So yeah, what do we have? So yeah, thanks for reaching out to Tal. Of course, I was in touch with him already a long time ago. The last time, I know he's busy with stuff as well. I don't want to bother him. I don't need to sit down with him and debug Liquid Apps, the DSP software. If you can get support for him and get other people to spin up nodes where I can then deploy my stuff, great. That's what we need. I don't need I can debug the stuff myself. I already added some. Right, as you guys know, I added this feature to Liquid Storage, which in my opinion makes it really interesting only, right? Because you can really use it as a Web3 backend for websites. Pure REST API is worthless for the browser because I cannot talk to it. But yeah, I'm just saying, I can debug this stuff myself, but I just not really motivated to do that. I want it to work, And again, if that was the only way forward, I would do it. I would revive this whole thing. I would maybe even fork the code base and tailor it. I mean, a couple of things that I would make differently. But I don't want to get too much into this. I'm scrolling a little bit here through the thing. Yeah, someone says dApp is dead. No need to bring it alive just for ZEOS. Looking forward to the video. Always felt that the dApp tech dependency was a weak point of the project. A lot of people felt that, and especially a lot of the top engineers as well. Yeah, they would like to see something like that, but rather natively. Again, you can make the argument from a security point of view that it's not really a trade-off having a set of extra nodes, but it introduces more friction. It requires the set of extra nodes to be alive, where if it's natively on EOS, it really just requires EOS to be alive, which is a multi-billion-dollar blockchain. So, it's just more security than a dead project where you don't even have a node. And where nodes only would come for ZEOS. I mean, right? If there's no other incentive for people to build on dApp, then why? If dApp only exists for ZEOS, right? Then it would make more sense actually to fork the project and tailor it then also for ZEOS. But yeah, again, it's cool. It's much cooler to be able to improve the blockchain protocol. I mean, to that degree, I mean, again, yeah, we're talking about a scaling factor of 100 from a pure WebAssembly implementation to pre-compiled in the Leap code base. This is huge. This is a game changer. So what else do we have? I know it's already long, guys, but yeah, some of you are, I know a lot of you were probably wondering what's going on. So, and yeah, I was dropping super long Telegram posts also. It's difficult to communicate all this what's going on. And again, I was working my ass off over the last months, and I'm really happy about the results. And if this is now getting integrated, the way I proposed it in my pull requests, that would be a game changer for ZEOS, and that would be also, very exciting for EOS itself, because it would make this private DeFi narrative possible. Thanks to ZEOS, to the third iteration of ZEOS, which is gonna be even more of a killer app than what we already have. I'm really excited, guys. I'm really hyped, and don't worry, it's not gonna take that long. So let me read. Yeah, people are discussing the app. Again, the ZEOS community is awesome, right? We have so many active members from the EOS community. We are at the bottom of the beer market, and this is so alive here. I love this, guys. I'm so grateful for your support. Please don't get this wrong. I was already expecting some disappointment, of course. Obviously, we're talking about this, and I'm building, and no one really sees anything. I know how this looks like, yeah, but what can I do? Help me getting DSPs up without me having to deal with this. This is really something that anyone can do who is a little bit skilled in Linux and JavaScript and maybe, networking, or networks or distributed networks or something like that. Again, you shouldn't even have to debug this node software. Yeah, that is what, is so annoying to me. That is the great irony. Best tech, no use. Yeah, it is great tech, if you want to build a serious application, not just a boring NFT exchange, come on, if you want to build a sophisticated application, scale on EOS, it's not so easy to do that without dApp, in my opinion. But then who's even building it? So ZEOS, that is a sophisticated application, and again, and when I started with this, it was no way at all possible to get this run natively on EOS. But, EOS, the software is evolving. There are great people working on this, and more things are coming. And so over time, these base protocols improve and things become possible all of a sudden, Is it then better to stick to the not so elegant, clumsy solution, or, spend the, let's say, 2 to 3 extra months and reinvent or, reiterate basically on your concept to make it work now, fully on-chain based on these new host functions, for instance? For me, there's not even a question, Again, we're so early. And yeah. So yeah, Yeah, if governments outlaw all this, I mean, this is completely expected for me. I can't wait for the day, actually, to be honest, as that will then separate, all these trash projects from the ones that actually, have meaning and purpose and that can resist the government tyranny. I mean, this is just completely expected, the crackdowns, and yeah. So yeah, a lot of chats going on here. Right, okay. So yeah, it would also not just require one DSP node. It would be great to see a couple of nodes, yeah. But just to showcase it, one node would be fine, of course. But again, I just have better things to do. Yeah, I'm working like more than full time every day, guys. Yeah, it's really, but working on this really awesome cryptography stuff. And there's also so much research to do. Yeah. Again, right now I'm in the process of choosing the right hash functions. There's thoughts that I didn't even make the first time when I started because I didn't even know what was important and what to look for, right? But now I understand all this. I know about the circuit efficiency. I know about how to build efficient smart contracts and all these things. So, I learned a lot, and I the way I'm doing it now, I look at every little detail to make it perfect, because again, it's fundamentally different if you are developing such a protocol on an application-specific blockchain like Zcash or Monero, right? All these blockchains that really only have to serve this one purpose, right? This one application that's built on top. Or if you build this protocol like what we are doing on a general purpose smart contract blockchain like EOS, it's fundamentally different, and I haven't seen anyone doing this even yet. So, we are very early, and I feel like I'm really ahead already with all the experience that I have now. So what I'm now building is going to be like really, really awesome. I mean, it's going to be awesome because it is so optimal, tailored for Antelope. Because I'm also able to tailor Antelope a little bit the way I need it, right? With adding these primitives now. It's just perfect, guys. It's just perfect. And so when you think about it, what the coincidences is, right? Could have been anything that they needed, but no, it was exactly this elliptic curve, exactly this library, exactly those functions because of the aggregate signatures. And that's exactly what the Zcash guys built their Zappling protocol on. So yeah, this is going to be our basis now for the third iteration. Okay, guys, I think I'll leave it at that. Maybe we can have a live conversation. I mean, I know I'm happy to answer all these questions. I read a few more earlier, but I can't find it so quickly. I don't want to get this too long and too boring. So I guess I pretty much shared most of what I wanted to say. Again, it's just amazing if you think about it, guys. Yeah, how Antelope is improving. Also, this whole instant finality stuff is super exciting. What it means to the previously rolled out IBC solution. What amazing stuff we are able to build, on these improved Antelope versions. It's really, really exciting. And ZEOS is getting better and better and better, guys. Yeah, and I know people already lose hope that there will ever be something. And for me, it's just so crazy, to think about this, because for me, there's no question anymore if there will be anything. I mean, there were still so many questions from myself when I started with this. Is it even possible to do it this way, that way, and all that? Now I have like so many ways to do it, right? Just about picking the best one. Yeah. So this is how better it already is. Yeah. But I understand, 2 years, and I came pretty much out of nowhere, right? Who am I even, right? But I mean, now with this library, which most likely gets integrated into Antelope. Sorry. I mean, that is something I'm really proud of. That is a major contribution to the Antelope code base. Very valuable. I mean, this enables like so much cool, cryptographically cool applications, that we can build on top of it. And yeah, one of it is aggregate signatures, which is being used inside Leap, right, for the new hot stuff. But, you can also build sort of contracts making use of that. And of course, the whole Growth 16 stuff. So, yeah. I hope I could cheer you guys up a little bit more. I hope the disappointment is not too big. Stay tuned. Thank you for all your support. Really, I'm so grateful. I mean, I'm so happy that Guillaume onboarded me now. I mean, at this point, the Pomelo funds, wouldn't even be enough for me to work full time on this anymore. That's the sad reality. Yeah. I haven't, completed my grant application at the ENF because I will follow a different strategy with Guillaume together now and the UX team, which will also, benefit the whole project and this community, I promise, in the long run. So things are just getting better and better, but I understand that a lot of this is also invisible, also it's not clever to share everything at any time, especially the things that are not so 100% yet, because it will just lead to disappointment, right? I mean, this is not a perfect example. Everyone was expecting this Halo 2 version of the protocol now being rolled out, and now this, right? Which is actually a good development, but in the short term, it's maybe disappointing. So sometimes it's just better also to not share everything. But I also, guys, you are so supporting. You're the only reason why I even came so far. And I feel obligated to be transparent, at least to a certain degree. And I want to be transparent. I mean, I also value your guys' input. And yeah, there's also some things I want to share over the next days. But first things first, so I thought this was the most important thing. There's actually another very exciting thing that I'm working on right now, which is also related to ZEOS, and again, this is all about making the protocol as perfect as possible. There are a few new mini projects that pop up, because of that. But that's fine, it's awesome. It's fun to work on this, and it makes it better and better. Yeah. So yeah, but more on that in the next days. For now, I just want to explain what did I work on the last month. So again, this BLS library, it was related to instant finality, but then because of the way I built this library and the performance numbers that we have now from this library, it enables me to redesign ZEOS, as an application in Antelope. I mean, it's just so funny how things go sometimes, right? But yeah, it's all good news and a lot of reason to remain excited. And don't worry, yeah. We're moving forward, yeah, but please don't name me too much on if there are too many variables, yeah. So this is also something about this third iteration now, which is fully smart contract based. There are no unforeseen things anymore, right? That can go wrong, like which was the case with DApp all the time, right? Then this goes wrong and this, then the node here goes down and all this. That won't happen on EOS, right? If it's a fully 100% dependency-free, pure EOS version, right? So that's also just so relieving for me, yeah, because I don't have all these, these variables, that I cannot control. So yeah, it's just getting better and better. And guys, yeah, I hope you can see that. Yeah, we are so early in crypto still. We are so early. But at the same time, you have a few dev teams like working really, really on these exciting things. And I think there's a lot of reason to be excited for EOS for the future. the stuff that we're building, that we are able to build on EOS. I mean, again, I know other blockchains might also improve, but now that I see more and more, what's going on behind the scenes in Antelope and the way I can redesign my stuff now, I mean, it's just super exciting. So yeah, that's it for now. I hope I didn't forget anything, but I would just suggest we continue the discussion in Telegram. And yeah, maybe we can do some kind of, like a Twitter space, but I would like to do it in Telegram and then instead of Twitter, because I cannot use my laptop there. That's annoying. So yeah, thank you for watching this and thank you for your support again. It really means everything, and please don't be disappointed. Please keep supporting this. The community is everything to me, and again, we're at the bottom of the bear market, and when this turns around and we are having all these awesome solutions ready for rollout, it's going to be very exciting. I think there's a lot of reason to look forward to that. Okay, cheers guys.